So we can say the probability of x, or the number of defectives, equals x values, be e to the minus k to the x over x factorial, where x can be 0 defectives, 1 defective, up until 100 defectives. But you might be wondering, this doesn't make much sense to assume that it is a sampling with replacement, because in inspection we usually do sampling without replacement, right? So maybe this assumption is not very reasonable. So to make it, I'd like to okay, I'd like to say that the more reasonable way is to use hypergeometric distribution. Actually, a hypergeometric distribution would make more sense, because this is about inspection of screw, and that would be sampling without replacement. Okay, so hypergeometric distribution is better in this case. So we don't want to use this. Okay. Assuming that, so because we assume that it is, when we inspect a product, we do sampling without replacement. But anyway, even though you know that this is a hypergeometric distribution, you can use binomial approximation to get the answer to hypergeometric. So now let's say we use binomial here. Okay, so we use binomial. Let's say we use binomial approximation. And this is binomial approximation. So that's one answer coming from binomial approximation. Another answer is that we further use Poisson approximation. So you might have another answer that looks like this. So please note that x remains in the answer, in this answer here, because they ask for the probability that a box contains x defective. Okay, so you must leave it in there. But if they say what is the probability that a box contains 7 defectives, then this is going to be 7, right? And this is going to be 7, so you get some values. But here they don't give you the actual values, so you must leave x like that. All right. Questions? No? No questions? A light bulb factory found 3% defective in a day's inspection. Okay. If 100 light bulbs are selected, find the probability that 5 defectives are found. So we're doing inspection of light bulbs. All right. Light bulb inspection. Our experiment is light bulb inspection. How many outcomes can there be? How many outcomes are possible? 2 outcomes. Defective light bulbs. We can find defective light bulbs or non-defective light bulbs, right? Find the probability that 5 defectives are found. We are interested in this, so this is success. The probability of success is 3%. Right? The probability of success, probability of defective is 3%. So this is inspection of products. So we should use the hypergeometric distribution, because it's is sampling without replacement. Okay, assuming that this is a sampling without replacement, so we can use hypergeometric distribution. All right. But we're going to use binomial approximation. Binomial approximation is valid because our condition is met. Our condition says, let's go back here. Binomial approximation to the hypergeometric distribution. Binomial approximation can be used when this applies. When the sample size is less than or equal to 5% of the total. So let's see here. Sample size n equals 100. All right. The total number of light bulbs produced in factory is much larger than 100. We assume that I don't know, in the whole factory it must be very large, so we can say that this is less than or equal to 0.05. This must be less than or equal to 0.05. Assuming that n are the number of light bulbs produced in the whole factory is very large. You know, it's much larger than 100. We don't know how many, but it must be much larger than 100 bulbs, right?